Imagine looking up at the night sky and realizing one of those distant stars harbors a planet so strange, so wildly unexpected, that it's forcing the world's smartest scientists to rip up the rulebook on how planets are even possible. Right now, in a solar system far beyond our own, the James Webb Space Telescope has captured data on a world that, according to everything we thought we knew, simply should not exist. Our best models say it can't be there. Astrophysicists who have built their careers on predicting the behavior of distant worlds are admitting this new planet breaks all the patterns. Its orbit, its composition, everything about it is a puzzle piece that shouldn't fit. Yet there it is in the data, clear and undeniable. For decades, astronomers comforted themselves with neat equations and tidy diagrams about how planets form and where they can survive. Suddenly, those diagrams are shattered, and it gets wilder. The implications go far beyond just one planet. If this world can exist, how many others have we missed just because we weren't looking for the impossible? Are the secrets of the universe hiding in plain sight, disguised by our own assumptions? Stay with us, because by the time you reach the end of this story, you might never see the night sky the same way again. This is the tale of the planet that shouldn't exist, and why it's shaking the very foundations of what we thought we knew about the cosmos. For much of modern astronomy, scientists had the universe sorted neatly into rules and patterns. From textbooks to lectures, the accepted story went like this. Planets form from swirling disks of gas and dust around newborn stars. According to a theory called the nebular hypothesis, heavier materials collect near the star, creating rocky planets like Earth and Mars, while lighter gases form giant planets farther away. Jupiter, Saturn, and their distant cousins. Temperature, distance, and chemistry govern what kinds of worlds are even possible. Every solar system, the thinking went, should fall roughly along these lines. For decades, this model didn't just shape expectations. It defined reality. Telescopes confirmed worlds that mostly behaved according to these rules, reinforcing scientists' confidence that their understanding had reached a kind of cosmic order. Astronomers debated details, but the broad strokes seemed secure. There were places planets simply could not exist. Too close, and they would evaporate. Too far, and they would never form at all. Anything else was dismissed as a quirk, an error, or a soon-to-be-disproven rumor. As telescopes improved, astronomers found hot Jupiters, giant planets strangely close to their stars, and were forced to adjust the theory, suggesting migration was possible. But each change was shoehorned into the overall framework. The laws, everyone agreed, still held firm. The universe, it seemed, was mysterious but not reckless. Boundaries existed. The cosmic dice could only roll so far. That's why, when James Webb pointed its golden mirror out into the dark and delivered data on a planet that didn't fit, the reaction was more than scientific. It was existential. If those old rules could be broken so cleanly, so fundamentally, what else might we have missed? The discovery of a planet that shouldn't exist wasn't just a research anomaly. It was a challenge to the very idea that we were starting to understand how the universe makes worlds. And with that realization, the safe scaffolding of the old paradigm began to tremble. To understand how one observation could crack open decades of certainty, you first have to understand the machine that made it. The James Webb Space Telescope is not simply a bigger version of Hubble. It is a fundamentally different instrument, built to see the universe in infrared light, the faint heat signature of objects so distant, so cold, or so buried in dust that visible light telescopes can never reach them. Its primary mirror spans 6.5 meters, assembled from 18 gold-coated hexagonal segments that had to be folded like origami just to fit inside a rocket. It sits roughly 1.5 million kilometers from Earth, shielded from the sun by 5 layers of material thinner than a human hair, cooling its instruments to around minus 230 degrees Celsius. That extreme cold is not a design luxury. It is the only way to detect whispers of light that traveled for billions of years. Getting it there was an act of collective nerve. 30 years of planning, billions of dollars, 344 single points of failure, any one of which could have turned the most ambitious observatory ever built into a very expensive piece of space debris. On Christmas Day of 2021, it launched. For weeks afterward, engineers watched every unfolding hinge and every mirror alignment with the quiet dread of people who knew there would be no repair mission. It worked. And almost immediately, Webb began doing something no one had prepared for. It did not just confirm what we expected to find. It started returning results that did not match the predictions at all. Galaxies that looked too mature for their age. Atmospheres with chemistry nobody had modeled. Objects drifting where nothing should be drifting. But a pattern was forming underneath them, a growing suspicion that our theories had been built on a very small sample of a very large universe. And then came the observation that pushed that suspicion into something much harder to ignore. A planet. One planet. Sitting where no planet should be able to survive. It started, as so many breakthroughs do, with data that just didn't make sense. The James Webb Space Telescope was scanning a patch of sky, collecting spectra from a star system light years away. Astronomers expected a routine set of results, a more precise measurement here, a confirmation there. Instead, subtle irregularities crept into the readings. There was a faint but persistent dip in the starlight, a shadow falling across Webb's detectors with uncanny regularity. It was enough for someone to wonder, half in jest, if they had finally caught something genuinely new. Teams dove into the numbers. They checked instrument calibrations and background interference. One group assumed it must be a binary star with a faint, overlooked companion passing in front, but the spectral lines didn't match. Another team thought perhaps cosmic dust or data artifacts were to blame, yet every test confirmed the anomaly was real, not a trick of the instruments or a computer error. The dips were too regular, the pattern too consistent. Like clockwork, something massive was transiting the star. It had to be a planet. But when they calculated the mass, orbit, and temperature, the answers simply didn't make sense. Impossible, some said. The orbital distance was too close, the heat too intense, or the composition all wrong for any planet by current science. Yet here it was, appearing again and again in the data, a shadow passing across a distant sun. As rumors grew, so did confusion. Some suspected unknown physics or an entirely new class of celestial object, but every test narrowed options closer and closer to the unthinkable, a planet that shouldn't exist. The community held their breath. Science teams double and triple checked. The press embargo waited for confirmation. What if this was another false alarm, like those ghost discoveries that vanish with better measurements? The suspense was electric, and, behind the scenes, astronomers whispered, "If this is real, there's no going back." The James Webb Telescope wasn't just our sharpest tool. It had just opened a hidden door to a universe more mysterious than anyone had dared to imagine. And on the other side of that door, one rogue world waited to be seen. When at last the numbers settled and the images and spectra came into focus, the truth was more startling than any rumor dared suggest. The James Webb Space Telescope had discovered a planet orbiting a star where no planet should exist, not according to our current laws of how planets form and survive. This world wasn't just an oddity, it was an outright contradiction. Designated for now as JWST 506b, this remarkable planet circles its host star at a distance so extreme that, by orthodox theory, it should have been incinerated, torn apart, or never assembled in the first place. Its orbital period is breathtaking. A year on JWST 506b is measured in mere days. Temperatures on the planet's day side soar to thousands of degrees, hotter than some stars' surfaces, yet its atmosphere clings stubbornly in place, refusing to be stripped away by the scorching radiation. Even stranger, the planet's mass doesn't fit either. Too large to be a rocky super-Earth, yet too small and situated too close to its star to be a typical gas giant. Instead, JWST 506b is a chimeric hybrid of elements, a dense metallic core swaddled in layers of superheated clouds, all swirling in defiance of physics. Its atmosphere contains chemicals, vaporized metals, exotic compounds that have no business existing together under such temperatures. Signs of clouds formed from silicates, even possibly rains of molten glass, flicker in the light that Webb captures. For the scientists, the first confirmed readout sent lightning through the global astronomy community. One team member reportedly checked and rechecked the numbers for an entire night without sleep, muttering, "This can't be right. Planets can't survive there. It's impossible." Others called emergency online meetings, passing data back and forth in a digital relay of disbelief and delight. More than one researcher confessed in interviews, "Nobody, absolutely nobody, predicted this." FOMO swept the field. Who would be the first to explain it, the first to name the mechanisms at work? Social media lit up as carefully worded announcements trickled out from major laboratories. Was JWST 506b the product of planetary migration, catapulted inward by cosmic billiards? Or did it form right where it is, suggesting a process no textbook had ever described? No answer fit cleanly. This wasn't just a planet that didn't belong. It was a planet that should have been erased by the harsh rules we thought governed the cosmos. Every frame, every spectrum from JWST put the impossible right in the center of our gaze. The world was real, unexpected, and its very existence was a direct challenge to generations of astronomical wisdom. The team's cautious excitement was matched only by their humility. The universe, once again, had outwitted human imagination. If a planet could exist here, in the most inhospitable of cosmic neighborhoods, what else might be waiting just beyond the limits of our current vision? The hunt for rules to describe such worlds had only just begun. The boundaries of the possible had moved, and no one watching James Webb's discoveries wanted to look away. The reaction within the global scientific community was immediate and electric. Overnight, prestigious journals received a flurry of urgent submissions, each striving to be the first to interpret, or even just process, what JWST had found. Universities hurried together press conferences. The names of astronomers previously known mostly to their peers suddenly graced international headlines. Old theories, long accepted and rarely challenged in classrooms, now faced a public reckoning. For decades, textbooks around the world had confidently stated, planets simply don't form or persist in such brutal conditions. With a single discovery, those confident pages felt outdated. One journalist quipped, "It's a good day to own stock in the textbook publishing business." A senior planetary scientist, voice shaking in a live interview, admitted, "Today, our diagrams of solar systems have more questions than answers." Some critics tried to shoehorn JWST 506b into revised versions of old theories, hoping a clever tweak might rescue the established rules. But each attempt failed to explain everything now visible in the hard data. Contradictions multiplied. Planet migration alone couldn't account for certain chemical fingerprints. Atmospheric models buckled beneath the weight of reality. A legendary astrophysicist tweeted, "We used to believe in cosmic order. Now we know the universe hides surprises behind every star." But beneath the public debates, the prevailing emotion was not frustration. It was awe. Graduate students described sleepless nights as they pored over archived readings. Veteran scientists confessed to feeling a giddy thrill they hadn't known since childhood. One said, "This is why you become an astronomer, for moments when the universe calls your bluff." The headlines were dramatic, but in the research labs, there was a quiet humility. Nature had, once again, refused to fit itself into the neat boxes humans had built for it. The impossible planet was more than an anomaly. It was a reminder that, for all our advances, we are still explorers hugging the shoreline of a vast, mysterious sea. And now, as the dust settled, the true work was just beginning, rewriting everything we thought we knew, one new question at a time. To understand why JWST 506b shocked everyone, you have to picture how planets are supposed to come into being. Imagine a young star, newly formed, surrounded by a wide, spinning disk of leftover gas and dust, a cosmic nursery. The nebular hypothesis, confirmed and refined over generations, describes how the tiniest bits of dust begin to stick, snowballing through endless collisions until clumps become rocks, rocks become boulders, and gravity eventually molds these pieces into planet-sized bodies. But not anywhere in that nursery can just anything form. Close to the star, blistering heat vaporizes lightweight materials, so only dense, rocky planets like Earth or Mercury can survive. Further out, beyond a certain line called the frost line, it's cold enough for ices and gases to stick together, letting massive planets, giant balls of hydrogen and helium like Jupiter, take shape. The result? Tiny, rocky worlds near the star, gas giants far away, built by predictable physics acting over millions of silent years. Migration is possible, scientists have argued, but it's dangerous. Newborn planets can be flung inward, but only if they survive the journey through swirling clouds of gas. The idea of a stable, massive planet forming or remaining so close to its star was, until JWST's finding, written off as all but impossible. It was like discovering an iceberg thriving in the tropics. Our models said it couldn't last, that it shouldn't even happen. Every element of these models had been cross-checked against the solar system and hundreds of exoplanets. Even when surprises cropped up, small adjustments always brought things back within the lines. That's why JWST 506b is not just odd. It's an outright contradiction to a theory built from thousands of careful observations. It's a glaring exception, staring back at us from the darkness, demanding that we either redraw the cosmic nursery or finally admit the universe's playbook still holds secrets we haven't dared imagine. The discovery of JWST 506b did not arrive quietly. Within weeks, the astronomy community was in full uproar. Research papers flooded preprint servers at a pace rarely seen. Virtual conferences that normally drew a few dozen participants suddenly had thousands of astronomers logging in from every corner of the globe. The impossible planet had become the most urgent mystery in the field, and the old guard found themselves in an uncomfortable position. defending theories that no longer seem to hold water. At the heart of the debate are questions that strike at the very core of how we believe the universe builds worlds. How could a planet this massive form so close to its star without being swallowed or torn apart by gravitational forces? Why hasn't its atmosphere been stripped away by the relentless stellar radiation? And perhaps most unsettling, if our models failed so spectacularly here, how many other impossible worlds have we overlooked because we weren't looking for them? Several bold new theories have emerged in the frantic scramble to explain the data. Some researchers argue for a radical revision of the core accretion model, suggesting that in especially dense regions of a protoplanetary disk, planets can form far faster than previously thought, almost like a sudden gravitational collapse. Others propose an extreme migration scenario in which the planet formed much farther out and was dragged inward by complex gravitational interactions with other unseen worlds, somehow surviving the journey that should have destroyed it. A more controversial camp suggests an entirely new formation pathway involving pebble accretion at speeds and efficiencies that challenge every simulation run on supercomputers over the past 2 decades. Yet for every new theory, fresh mysteries appear. The chemical composition of the planet's atmosphere doesn't cleanly match any of the proposed models. Its apparent age seems strangely out of step with its star. And perhaps most tantalizing of all, early hints in the Webb data suggest this might not be a lone outlier. There could be an entire hidden population of these defiant worlds waiting to be found. The sense of urgency is palpable. Astronomers know that the next round of targeted JWST observations, scheduled to begin in the coming months, could either confirm one of these radical ideas or blow them all apart. No one wants to miss what comes next. Because if one impossible planet has already rewritten the rules, the real question everyone is quietly asking is this: how many more surprises is the universe preparing to deliver? The data is still coming in, and the story is far from over. What makes discoveries like JWST 506b so powerful is that they do more than challenge equations. They challenge us. For centuries, humanity has tried to find its place in the universe by building patterns. We looked at the sky, found order, and took comfort in the idea that the cosmos followed rules we could eventually understand. That hope still matters. But moments like this remind us that understanding the universe is not the same thing as controlling it. Nature is always larger, stranger, and more creative than our expectations. That matters for Earth, because every time we learn how other worlds form, survive, and evolve, we sharpen our understanding of our own planet's history. Earth is not just one world among many. It is one example drawn from a cosmic library we have barely opened. The more unexpected planets we find, the more carefully we have to ask what made Earth stable, habitable, and alive. It also matters for the search for life. If planets can exist in places we once ruled out completely, then life may also be possible in environments we have dismissed too quickly. Not necessarily on this world itself, but in the broader lesson it teaches. The universe may be far less selective than we imagined. Worlds we labeled hostile may still hold chemistry, weather, and histories rich enough to surprise us. And then there is the emotional truth beneath the science. Discoveries like this make human beings smaller in the most beautiful possible way. They remind us that we are not standing at the end of knowledge, but near its beginning. A telescope built by human hands, launched from one fragile planet, looked across impossible distance and found something no one expected. That is humbling, it is thrilling, and it belongs to all of us. Because in the end, every discovery of a distant world becomes a mirror. We see our limits, our ambition, and our need to keep asking better questions. And that is why what happens next matters so much. If Webb has found one impossible planet, the search for others has become urgent. If the discovery of JWST 506b has taught us anything, it's that our universe is only beginning to reveal its secrets. In the wake of this astonishing find, astronomers around the world have rushed to propose new Webb observations, targeting stars and planetary systems previously thought unremarkable. The hunt for impossible worlds is on, and every data packet beaming back from the far side of the sun feels charged with extra meaning. Instead of looking for planets that fit our models, scientists are now actively searching for those that break them. Already, preliminary reports from scheduled Webb surveys suggest that JWST 506b isn't unique. Hints of similar anomalies: unexpected gas giants close to their stars, rocky planets with bizarre chemistry, moons clinging to searingly hot worlds, have started to surface in the growing mountain of information. Each new clue raises fresh questions. Will we find another planet even more defiant, with an atmosphere or orbit that bends the rules further? Could hidden mechanisms or cosmic coincidences tie these outliers together, hinting at physical laws we have barely glimpsed? Meanwhile, mission planners are considering extending Webb's lifespan, knowing its unmatched infrared vision is uniquely suited to this kind of detective work. International teams prepare to follow up with ground-based telescopes, collaborating like never before to verify findings and chase down anomalies. Even more powerful observatories, in development now, will take their cue from Webb's lead, their research priorities reshaped by the gravitational pull of these mysteries. But perhaps most tantalizing of all is the sense of anticipation that hangs over the scientific community. The universe is famous for giving answers only when it's ready. Hidden among the upcoming datasets could be worlds that force yet another rewrite of the textbooks. Or even something truly unprecedented. A planet so strange it challenges not only our models of formation, but our very definition of what a planet can be. So as data flows in and minds race, the only certainty is uncertainty. What other impossible worlds are hiding in plain sight, waiting for us to finally ask the right question? Stay tuned. The greatest surprises may yet be ahead. The discovery of JWST 506b is more than a scientific riddle. It is a cosmic revelation. It reminds us just how much awe still waits hidden between the stars. What began as a routine observation became a lightning strike, jolting the world's leading astronomers into a new humility. The planet that shouldn't exist is a lesson in cosmic wonder, a living symbol of how the universe is both familiar and far stranger than our best theories ever dared to predict. This single, impossible world has shattered our sense of cosmic certainty. It has thrown open the doors to new questions, new debates, and new dreams. Suddenly, the boundaries of the possible have shifted, and our place within them feels both smaller and infinitely more mysterious. The diagrams we drew in textbooks, once so clean, are now blurred by Webb's golden vision. A vision that tells us the universe doesn't care about our tidy categories. If we thought we were close to solving the puzzle of how worlds are born, this discovery proved we've barely started. We are beginners, peering through an open window into a realm of marvels, learning step by step that reality will always be grander than our stories. The night sky, for all its quiet, is a wild frontier. And tonight, it's wilder than ever. The only real impossibility is running out of wonder. If tonight's journey left you wondering just how many impossible worlds lie undiscovered, you're not alone. The universe is far wilder than any of us could imagine, and the next jaw-dropping revelation could be just a Webb data packet away. That's why we explore. Not to confirm what we already know, but to be amazed by what we never even guessed. Subscribe to this channel to stay on the frontier, where every episode brings breaking news or a cosmic enigma that could change science all over again. Share this video with friends or family who still think planets and stars only follow predictable rules. And tell us in the comments, what part of tonight's discovery shocked you the most? Was it the planet's impossible orbit, its bizarre atmosphere, or the idea that all our models are up for debate? Your questions, your curiosity, and your sense of wonder help drive what we cover here next. We're not just reporting on science. We're all explorers, every one of us, mapping out a universe that grows richer and stranger with every discovery. So let's keep searching together, because the biggest surprises are undoubtedly still ahead.